Welcome to the deep dive. Today we are really tackling a big one, a safety system that's, well, arguably one of the most important ever fitted to an airliner. The Ground Proximity Warning System,
Yeah,
GPWS.
absolutely. It's a lifesaver, plain and simple.
And if you're out there prepping for those, high-stakes theory exams, or maybe you just really want to get your head around what stops aircraft hitting terrain when they shouldn't, well, this deep dive is definitely for you. We're aiming for mastery today.
Mm-hmm.
We're focusing on something pretty grim, actually. Controlled flight into terrain, CFIT.
Yeah.
It's when a perfectly good plane, flown by a qualified crew, just flies into the ground. It's a persistent nightmare in aviation.
It really is. And GPWS and its smarter successor, EGPWS, they're the last line of defense, the absolute final backstart.
So our mission today, break it all down. Every mode, every input signal, all those specific numbers, altitudes, speeds that you absolutely need to know. We want to go beyond just memorizing facts, get into the why behind it.
That's the plan. GPWS isn't just some random alarm going off. People sometimes think of it that way, maybe a bit annoying at times.
Yeah, the nuisance alert idea.
Exactly. But it's actually a really sophisticated bit of safety thinking. It's designed specifically to catch those moments where things go wrong, maybe pilot error, maybe distraction, could be equipment failing, or just, misreading a situation that's changing fast.
It's like a digital co-pilot constantly watching.
Yeah.
A digital observer checking, is this flight path actually safe right now? Okay, so foundation first. Where does this system actually operate? Is it always on?
Good question. The classic GPWS, the one we're starting with, it has a specific window. It operates automatically, continuously monitoring things when the aircraft is between 50 feet and 2,450 feet above the ground. Actual height, AGL.
50 to 24, 50 feet AGL.
Got it.
That's the magic zone for the basic system.
That's the core operational envelope, yes.
Okay, let's unpack the system itself then, the hardware. You look at a diagram, what are the main bits? What makes GPWS tick?
You can really break it down into three main chunks. You've got the inputs, the sensors feeding it data. You've got the central processing unit, the CPU, that's the brain doing the calculations. And then the outputs, that's the alerts and warnings you actually hear and see.
And the CPU isn't just processing, right? It's checking itself.
Oh, yeah, absolutely critical. It's constantly running self-tests. Am I working okay? And just as importantly, it's checking the signals coming in. Are the inputs valid? Is the radio altimeter talking sense? Is the ADC data okay? It monitors for failures in itself and in those crucial input signals.
Okay, let's dive into those inputs. This is fundamental, especially if you're facing exams like question 4 asks about. What exactly is feeding information into this brain? Right, got to be precise here. There are 5 main sources providing the data. Okay. First, and arguably the most important, the radio altimeter, or RA. Gives you your actual height right now above the surface, AGL, the critical one, precisely. Second, the air data computers, the ADCs. These are busy. They provide 3 key things: barometric altitude, barometric rate of descent, and Mach number. Okay, so one source, 3 data points.
Third, the ILS receiver, specifically for checking if you're dipping below the glide slope on an approach.
Makes sense.
Fourth, the landing gear position indicators. Simple enough, is the gear up or down and locked. And fifth, the flap position indicators. Again, pretty self-explanatory where the flap's set. So 5 sources: RA, ADC, ILS, gear, flaps. That covers question 4's options directly. Option C looks like the winner there. Exactly. And notice, while we say 5 sources, the CPU is actually juggling maybe 6 or more individual signals, right? Baro altitude, baro rate, Mach, ILS deviation, gear state, flap state, RA height. That's why the input monitoring is so vital. If any one of those signals drops out or looks dodgy, the system flags a fault. It might inhibit a mode or give you a specific fault message.
Let's stick with the radio altimeter for a second. You said it's maybe the most important. It gives AGL. How does it actually do that?
Yeah.
Question 1 touches on this, asking about the beam.
Yeah, it's pretty clever tech. It basically fires a radio beam straight down.
Okay, downwards, not forwards like some radar.
Definitely downwards. It measures the time it takes for that signal to bounce off whatever's...
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best